Hi, this is lesson 12.6, limits and continuity. What we're going to do is we're going to be going from two space, where we know a lot of the definitions that we do have, to three space. And then the difference is two space deals with a left and a right. So if I want to do the limit, I'm just looking at a left and a right. In three space, we want to deal with an infinite number of directions heading to the one point. It makes for a few more subtle points, but a lot of it does become the same, and then you'll see some of the nuances that you get in the homework. So example 1, find the limit as x and y goes to 0, 0. So now we have two coordinates that are going to a coordinate pair, and then we got to look at the situation with our function. Now the problems with the function is that you have to realize that you get 0 over 0, you get different things that happened before, and we have to be careful of some of those subtle points. But here, let's just try direct substitution. If we do direct substitution, we're going to get 0 plus 0 all over 1. What does that become? Well, that is 0. Let's try another one. If we do the exact same function and we go from 1 to 3, that's going to be 1 plus 9 all over 2. So my answer would be 5. So direct substitution usually works. And there are some other nuances that will come about. I don't know how much we're going to deal with them here, but we'll see what happens with the homework. So now we have the definition of the derivative. Of a limit. So we take f has a limit L at the point AB, written f of xy as close to L as we please whenever the distance from the point xy to the point AB is sufficiently small, but not 0. Well, that's just this right here. Okay, so this is the same idea that we had in two space. Then we want to go ahead and use direct substitution whenever possible. If you get division by 0, you may have to look at it more closely. If you can't, if it's 0 over 0, then we have to look at maybe coming in from different directions and play around with it a little bit more than what you are used to in two space. Then definition of continuity. A function is continuous if the limit exists and the point exists, and then those two are equal to each other. Same thing as in two space. So here's one of those examples now. Explain the continuity of g of xy for this function and this function at 0. Okay, so we have it undefined and it's just piecewise like we've done before. Plugging in 0 and 0 yields 0 over 0, so this is where we do have a problem. So what we can do is maybe pick points that are in and around that area of the 0, 0, and then maybe do some limits or find out what's going on with the function there. So let's look at what happens when we head in on the x-axis. Let's call this point x0. And as x0 tends to, well, the x goes to 0, let's see what happens with our function. G of x0 is going to be equal to x squared over x squared. What does that equal? Well, that'll equal 1. And remember, it's a limiting process, and so that's what we're dealing with here. So we have the limit as x goes to 0 of g of x comma 0 is just equal to 1. Now, let's do the same thing, but let's pick a point here, 0y. Now, what happens as the limit as y goes to 0 of g of 0y? What's going to happen there? Plugging in 0, I'm going to get 0 over my y, which will equal 0. And so the question is are these two the same? So is this 1 the same as this 0? No, it's not. And so if I have a 1 coming in here, the limit is going to go towards 0, and another one coming in here on this purple is going to equal 1. They don't equal each other, so the limit does not exist. Are we continuous? No, because the limit does not exist for that. So this is an example of some of the subtleties that may occur when you do get situations that aren't direct substitution. You can't figure it out straight away. So maybe pick points going from different directions to figure out if the limit is the same. They have examples in the book where it's not even on the axes, where you do it on a line, y equals mx. So you can look at that one and we can work that one together if you have trouble, but try it and see what happens. Now part B asks, is g of xy the same function continuous on the intervals where of the rectangle where x is between -1 and 3 and y is between 2 and 3? Now all this is saying is, okay, I'm not at 0, 0 anymore like I was up here. I'm at different places. Am I continuous? Well, if you observe this function right here, the only time we're going to have problems is when the denominator is 0. When are we going to have the denominator 0? Well, that's only at 0, 0. Am I going to get 0, 0 out of this at all? And the answer is no. I do get a 0 in this portion, but when I add it to anything that I get in this portion, it will not be 0. So I don't have division by 0. So the answer is yes, because we have no division by 0 in this region. Okay, so this is I think it's pretty straightforward. The explanation in the unit I don't like exactly, but I think it's very similar setup to what you did in 2-space, just with those extra nuances. Now, they also will give you contour diagrams. When you have contour diagrams, the level lines have to go to the same value. So remember that level lines don't cross each other if they're of two different heights. So if you go to a certain point and you approach 4 from one side and 57 from the other, you will not have a continuous function. And that's similar to what happened here. Okay, so we had things going to different values as we approached a certain point, and so then the limit did not exist. So when you look at the contour diagrams, look for that. All right, here is your gift, and then you also have a Unit 12 review gift that you can start working on for the Unit 12 test. Thanks for listening. Have a great day. Take care.